And we did have problems with people. We did have problems with people not having VApps, but we have gone through, and hopefully if you were missing a VApp, you should have it by now in the projects section.
Okay. So the first thing that I want to go over is we have a sign up form. So if you're not already receiving emails for Malware Club, if you're already on the sign up list, you should have received an email tonight. But if you didn't, then you're going to want to go here to join.malware.club and sign up. And that way you can receive VApps as well as emails updating you on club meetings. So everybody who signed up already should have a VApp. If you don't, please email me and we'll figure that out for you. Okay, so the first thing that I want to do is create snapshots in our VApp. So that way, while I'm presenting to you about JavaScript, the snapshots will have time to finish, and then because we're going to be going over a demo. So first I'm going to go over some slides with you related to JavaScript malware, and then we'll be looking at a JavaScript sample. So the first thing that I'm going to do is show you just very briefly how to create a snapshot in the project section of the IA lab. So let me share my browser.
Is the JavaScript that you have malicious in the sense that it does permanent damage to the VApp, or does it matter if they have a snapshot?
You know, it doesn't really matter for this case because it's an older JavaScript sample. So the server that is not currently delivering malware, but just to be on the safe side, we're going to create snapshots. And it's good to get in that habit because later on we'll definitely have that issue where we'll be analyzing live malware samples that could be malicious. So you should see now, if you've already signed up, you should see a you should see a VApp in the project section. So you go to IA Lab and then projects, and then you should see a VApp right here. So you go to actions, then snapshot, then create snapshot. And so that will be ready in time for our demo. So let me go back to the slides.
If anybody has any problems getting to the projects, just raise your hand and somebody will come help.
Okay. Yeah, so especially don't want to run the snapshots on your local machine. You're going to want to run that on the IA lab. So I want to go over a little bit about the background between about JavaScript attachments, you know, how they're used as malware, some different topics related to JavaScript malware. So let's get started. So just first, I want to introduce what is JavaScript. So JavaScript is a web programming language. It's used to add dynamic components to web pages. It's used for form validation and variety of dynamic features. But the reason we're interested in JavaScript is because it can be used for malicious purposes. So it can be used for as a delivery mechanism for malware. So usually, so there are two different primary ways that JavaScript is delivered as malware. The first way, the more prevalent way is the malicious actor sends a phishing email, and then the victim will download JavaScript onto their desktop. And since there's something known as the Windows script host on Windows, and that is an automation tool that's used for administrative tasks, but it supports JavaScript natively. So when a victim clicks on a JavaScript file, it will run through the Windows script host, and that will allow, so it's essentially the JavaScript files can be run on the user's desktop without any additional installations required from the user. So that is why JavaScript is prevalent as a delivery mechanism for malware. It's also used sometimes for exploit kits, so that would run in the user's browser. But exploit kits, we've seen a large decline in exploit kits over the past few years, so we'll be looking exclusively at JavaScript delivered on the desktop. So an exploit kit is basically, basically a type of malware that it will start as JavaScript will be the delivery mechanism in the browser, and then it will download additional content onto the victim's computer. And then this serves essentially as a way so the exploit kit will check like what operating system is running and different software on the computer. And then the exploit kit will then know which exploit to deliver to the target system. But we won't be looking at exploit kits right now. So I believe I already explained most of this. JavaScript is used as an attachment. So it's used as a delivery mechanism for additional stages of malware. So say you have a Trojan or a keylogger or crypto jacker. In order to get that malware onto the victim's computer, first of all, you need a delivery mechanism. So JavaScript serves as that delivery mechanism. And then what the JavaScript will do is download whatever the functionality of the malware is whatever the malware is, it will download that onto the victim's computer. And there may be intermediary stages of malware such as PowerShell, Python, or even additional JavaScript code. So I've discussed this a little previously. Essentially, the Windows script host is an administration tool that's on Windows by default, but it supports, you have the JavaScript, it supports JavaScript by default. So that means that on the user's desktop, you can run JavaScript by default. And then also Windows Script Host provides access to the WSH object. And what that is it's an object that Windows Script Host provides that allows a variety of functionality that can be used for malicious purposes. So it provides functionality that allows you to use the Windows registry. It allows you to read and write to files. It allows you to make network connections. And we'll see a couple of Windows Script Host methods used tonight in the malware that we'll be analyzing. But just here's briefly a few different methods used in the Windows Script Host. So Eval is actually, I just included this. Eval is actually not through the Windows Script Host. It's a natively supported by JavaScript. But what that will do is it will evaluate a string of data as actual JavaScript code. And we'll be discussing this in the next few slides. But essentially, once JavaScript malware will be obfuscated. So that means it will be encoded in a way that makes it difficult to read, and for various reasons that we'll be discussing. So in the JavaScript code, there will be usually a function that's used to deobfuscate deobfuscate the code. So that means returning it back into its original format. And then when it does that, it will be deobfuscated string. So in order to evaluate that string as actual JavaScript code, the malware will need to run the eval function. And then some WScript objects here. So here's the WScript.shell object. This is an object you'll see very commonly in JavaScript malware. So it's what it sounds like essentially. So it allows you to interact with the Windows shell. So that will allow you to accomplish any tasks that you can accomplish using the Windows shell. So reading and writing the files, registry connections, making network connections, displaying various information about the system. So this is a very important object that's used in JavaScript malware. And then you also have the adodb.stream object. This is used for working with a stream of binary data. So often JavaScript will pull like a file, an executable file from a domain that's hosting the next stage of malware, and it will download that onto the target system. But then it needs a way to write that malware into a file. So that's where the adodb.stream object comes in. So it will take the content that was retrieved through an HTTP request, and then it will get that as the HTTP response, and then adodb.stream will be used to write the executable file that was delivered in the HTTP response to a file.
Hey,
And
Odin,
then- yes.
could you go back to the other slide?
This
So
slide.
so one thing I wanted to interject is you can also use eval in other languages like Python, and you can also use it for non-malicious purposes. Right now, we have a reverse engineering tool that does some brute force deobfuscation, and we have strings, and we set it up to have various inputs go into the string, and then essentially the string is then compiled and made into executable code, and then the eval will then go and evaluate it. So just want to point it out that you can also use some of these things for non-malicious purposes.
Yes, that is correct.
Also want to add something else. This eval function, if you're trying to use it on EDR, like endpoint detection response softwares, it'll be detected as and flagged as malicious. So I tried this before on macOS on CrowdStrike, and it was detected as malicious. So if you have eval inside your JavaScript, you're doing some just red teaming or creating like a malicious file or something, it'll be detected. So I don't recommend it.
Odin?
Okay, yeah, thank you. All right, so the next, so there are a few other methods. I'll just go over these very briefly. So this is another, so the scripting.file system object is another way to gain access to the file system. The XML HTTP object is used to make HTTP requests to retrieve the next stage of malware. And then wscript.arguments, sometimes malware will need arguments supplied to it on the command line in order to run. So wscript.arguments is used to pass those arguments to the command line. So obfuscation. So this is a very important when looking at really any type of source code level malware, but JavaScript, through what I've observed, JavaScript uses obfuscation. Nearly on all the samples I've looked at use obfuscation. So what obfuscation is it's used by malware in order to hide certain aspects of the code. So instructions are added to obscure the functionality of the malware. And then this encodes the source code in a way that makes it very confusing, or sometimes even, well, sometimes very hard to read unless deobfuscated. So the JavaScript malware, to execute the obfuscated code, it will first have to restore the deobfuscated code back into its original form. I briefly mentioned this when I was describing the eval function, but yeah, we'll execute the obfuscated code. It will deobfuscate the code, so it will return it back into its original format. Then it will be in the form of a string, and then it will use eval to evaluate that as the next stage of malware. So this sometimes the malware will go through several stages of obfuscation. The more advanced malware will generally go through many different stages of obfuscation. And so there are two primary reasons for obfuscation. One reason is it can be used to get around some types of signature detection systems. And then also another reason is just to make the malware more time consuming to decipher. So this will basically buy more time for the malware analyst to be able to use the malware before it gets detected by malware analysts. And then, because once they detect it, then they'll write signatures for that malware. They'll, based on indicators of compromise, such as the domain names that it beacons out to, IP addresses, other things such as, other things such as like the hash of the file. But so basically, the more it's obfuscated, the more effort it will take to deobfuscate it. But since we are dealing with source code level obfuscation, the malware authors are somewhat limited in how they can deobfuscate the malware. So JavaScript will need we'll need valid function calls, if statements, loops, and variables in order to recognize it as valid JavaScript. So we can basically use this information to decode, or we can use this information to deobfuscate the malware. And then you can use either static or dynamic analysis techniques. So static analysis is performed without actually executing the malware, whereas dynamic analysis, you're executing the malware. Generally, so static analysis can sometimes work. A dynamic analysis process is faster and more efficient, but static analysis can be useful if you want to gain better insight into the malware's functionality. Usually I'll do is a hybrid approach. So I'll usually do a mix between static and dynamic analysis. So I will look for key variables and functions, and then I will usually a technique known as hooking eval, which I'll discuss a little later, or I'll just use wscript.echo to print the variables, and then this will allow me, so this is kind of like a mix because I'm running the malware, but I'm also statically tracing through the malware. There are also other dynamic analysis techniques, such as using Visual Studio's debugger for analyzing JavaScript code, but we won't get to that for this lesson, but it is very helpful if you do a lot of analysis of malware analysis of JavaScript. So wscript.echo is, so it's a method that's used to print JavaScript code, to print the JavaScript code to standard output. So this will be useful if we want to see the result of a particular variable. So basically to retrieve this, to run the JavaScript and see the results of wscript.echo, you need to either use cscript or wscript, which so I'll go over those now. So wscript is used to, so what that does, when you run wscript, it will print, basically it will print the result of wscript.echo to a pop-up window, whereas cscript, it will print it directly to the command line. I found cscript to be more helpful during malware analysis because it will, if I'm obtaining the next stage of malware, I can just copy it on the command line. I can't copy the text if it's in a pop-up window, but I can copy it on the command line and then paste it into a text editor such as Sublime. And then the exit command, what that will do is, well, basically nothing. So that's not a valid function in JavaScript. So that will just cause the code to cause an exception, which is good. So we prevent the rest of the malicious functionality from running. And then let me look at the next. So hooking eval. So that's something you can do if eval isn't always used to run JavaScript code, but when it is, you can use hooking eval, which is even easier because you can just, so you can change the functionality of eval to instead print the results of whenever eval is called, instead of, evaluating it as JavaScript code, it will instead print the code to standard output, which is helpful if because eval is called right after we deobfuscate the code. So then when we replace the functionality of eval with wscript.echo, instead, it will just print it to standard output. So then we'll get the resulting deobfuscated code. And then I discussed wscript and cscript previously, but then here's just some photos of it if you want to see a visual representation. So cscript prints the results of wscript.echo to standard output. And then on the right, wscript will print it to a pop-up window. So next, text editors. So text editors are helpful because they have syntax highlighting, and also you can use the replace feature. So that will allow you basically when you're renaming. So when you trace through the code, often the variables will be obfuscated. So like the variables will be random, hard to understand names. So a good technique is to go and rename all of those variables, and that way you can more easily trace through the code. So you can use text editors will have a replace feature that will allow you to do that. And yep. And so there are several text editors you can use. I like to use Sublime. You could also use Notepad and Visual Studio. So that concludes the slides. Now we're going to go through a malware demo. So we're going to show you an actual malicious sample that makes use, a malicious JavaScript sample that makes use of some obfuscation. So Evan is going to start that demo, and then I will, he'll do the first part of it, and then I'll do the next part of it. So I'm going to hand it over to you, Evan.
Sweet, thank you, Odin. Just give me 1 second as I transition over to sharing my screen.
And I just need to go plug in my laptop, so I'll be back in just a second.
No, I cannot. I can get it a little closer, but yeah, all right, cool.
Live demo time shortly. And just navigating to IALab, right?
So just go to ialab.edu, and we'll be able to kick this off. Then it'll be projects there. And since you guys have already taken those snapshots, the machines should be already powered on currently. And so we'll be using the Flare V, but is that rough? Oh, okay. I was like, yeah. You can follow on in Remnix if you like, if you feel comfortable enough. What is going on? That's so weird. Oh, okay, there we go. Yeah. But I'm going to be walking you through in Flare. So we'll just go ahead and get the remote console going.
And if you haven't done remote console before, you got to download that. We do recommend that. It's much higher quality than the web console, which is like garbage, right?
Oh yeah, complete garbage.
Yeah, it is. That's true.
And so just go to drive.malwr.club. And in the meeting 9/15 JavaScript folder, you'll find the sample.zip that we're going to be downloading. From there, you can just right click on it, go to 7-zip, extract a sample, and it's got a password, and it's just the MALWR club. Just to repeat that one more time, it's the MALWR club. Seconds to get. It's on right now. But... Oh, yeah. All right, so to open this up, we're just going to right click on it, and open Sublime Text. Oh, we're able to download it.
I didn't hear the URL.
Oh, yeah. So it's just
URL.
drive.malwr.club. And then it's in that 915 meeting folder.
Could you maybe type the spelling of it into Sublime,
Yeah, totally.
like as a comment, so that way they could see it?
This thing?
Never mind.
Oh, okay. Sweet. You guys all good?
Which file was it again?
It's in the folder, the 9/15. I can bring it back up again on screen for you. So we've got that meeting 9/15 JavaScript folder. And like from the original spot, you should find it just like right there. It'll be like right up there on the screen. It's the MALWRCCLUB.
What's the password?
The MALWRCLUB.
That's a weird password.
All right, sweet. So just to kick this off,
Anybody need help? Anybody else need help?
all good?
Capital P. Password. 1 exclamation mark. Password 1 exclamation mark.
Sweet. All right, so just to, oh, didn't you get it?
You can go.
All right, cool. So with the this malicious JS file, you kind of have to like get a good way to jump into it. You can't just jump into it because in a lot of the more advanced ones, there can be tons of different functions, tons of different variables. And if you just jump into a random function, you're going to end up in trouble pretty quick. So starting here, though, since it's running from the top down and the first commands aren't within a function, we can just go ahead and look at those. And so it's actually pretty cool because it's kind of funny how they ended up doing this, that we've got 2 variables declared with obviously kind of like funky names, but they use the get time. And then, so you see that get time and the date is assigned to that BEB variable. And then we've got the BEB right below that on line 2 plus 10,000. So a great way to kind of look at these, if you don't know how to like figure it out, like see what's going on, is just to Google like get time JavaScript to see what's going on. There's so much like different malware samples written in different languages. You're not going to be like fully proficient in all of them. So Google is your friend when it comes to these kind of things. But as it turns out, these are actually so it uses that get time method, and it returns the current time in the Unix epoch time format, which is the number of milliseconds since January 1st, 1970. And so the way that works then for that second line is it adds 10,000 to the original get time, which means it basically just adds 10 seconds to it overall. And then you've got that while loop on line 3 that looks at the get time again and uses the W script sleep. So it's comparing the original time to the new time, which is 10 seconds later, every second. So you see the like 1,000 down there. So 1,000 milliseconds is a second. And so it checks every second. And if 10 seconds hasn't passed yet, it won't continue on. which is kind of funky given that they could have just used like sleep, but it works. And then right below that, we can observe a send request function. And it's being passed two different variables there. And you'll see it looks pretty crazy what's going on down there from the if to the for. But right now we're kind of just looking at it, an overview. We're not going to deobfuscate anything just yet. I'm saving that for Odin because he has fun doing it. But we'll see that those two, the QUZIBK and the NFAAP are passed through to it. And we've got those original, the for loop up there that is doing something with the original variable's length, and it's probably iterating across it and assigning to the RIV variable there. Let me get a little screenshot here so I can kind of illustrate that a bit better. So we've got that QU at the top, and down here, that's filled empty. But then in the for loop, we've got it iterating across the length with that NIZZLI iterator, and they're being reassigned to the RIV ONKCA, and then that is passing itself to a new function. And so that's just interesting to keep in mind for later. Like we're not going to fully dive into that right now, but just for the overview. And then we get to the kind of the meaty area of this send request function. So the function name itself isn't strange. It's called send request. I think it does a pretty good job of detailing what it probably is meant to do. And so we'll see that the MSF XML2 XML HTTP ActiveX object is being called right there. And that's already interesting. So if you didn't know what that was, if you were looking at this, it's great to just go ahead and Google that just to see a good definition of like what it fully does. And but obviously here on the second part of that is it's opening a variable there and it's doing a post request. And so we can infer from that that it's probably sending a post request to like a web address or URL basically. And then it's sending that other one that was iterated across at the beginning of the send request function, the RIVO. Hello, there we go. And then we can see the there's a variable down there with the return status. And if the status was 200, and that's a successful access basically for that web address, it'll continue on. And it does all kinds of other things down here that we don't technically know what yet. And then scrolling down, before we get to this area, we can see that farther down, there are some funky functions going on. But they're all using different functions within themselves and commands that manipulate strings in some way or form. So we've got like from char code, length, substring, and they're all being passed different values themselves and then returning those values afterwards. So it would be a good guess before fully investigating just to know that those are most likely doing some form of deobfuscation or some form of obfuscation, or maybe there's just some kind of trash function, which sometimes just fill up these types of malware samples. And so going back up to the middle area, we can see that there's 4 different variables declared there. And looking at them, one of them is not quite like the others. It's quite a bit longer, which could give us some good clues about this. They're all calling the same function and it's passing a string to it. But so when you're looking for like kind of important variables within a malware sample, it can be so obfuscated that you won't recognize anything at first. But in this case, you can kind of take a good guess to what this second line on line 52 is. So this guy has all the things that a web address would normally have. So it's got like the period, the colon, the slash, things like that. And these other ones are pretty short, but they're also important to the running of the program just to figure out what they are. But just as a after going through the top and exploring the malware, that might be another good like starting spot if you were going through this on your own to further dig into what those values represent. And then going on further down, we see that Odin left a wscript.echo in there, but there's the send request with a TID and AQOB. And so its TID is right up here on line 53, and then AQOB is right here on 54. So it's passing those two to the send request function. But the cool thing also is this long one that looks a lot like what an obfuscated web address looks like, the IRMYK one. If we go back up to send request, we can see that that open post is sending out to there. So that kind of identifies that like that, yeah, that is an obfuscated web address right there. But after that, I think I can hand it off to Odin so that he can dig into those really cool deobfuscation functions.
Okay, yes, thank you, Evan. So I will share my screen now. Can everybody see my screen okay?
Hey, Odin.
Question, Odin. Is this the original file that you downloaded or like from the internet or something? Because I see the syntax is beautiful and it's correct, and usually be like a one line, code or something.
Yeah, so this syntax, yeah, this is the way that I downloaded it online. The only thing that's different though is that I accidentally left a wscript.echo statement in there, like around line 55. But other than that, yeah, this was how I got it online.
Perfect. Thank you.
But my screen is showing okay, right?
Yep.
Okay, let me just enlarge my text editor a little bit. All right, so.
Probably go full screen on the VMRC. That would look a little bit better.
Okay, yeah, that probably would.
Thank you.
Mhm.
If anybody has any questions, raise your hand.
All right, so I'm going to just start right here and kind of like trace through the program. So here we have 4 different variables being declared.
Could you
You
maybe
see-
make this font size a little bit bigger?
Yeah, sure. How's that?
Better.
Does it need to be a little larger?
It's fine.
So here are 4 variables being declared. So these are, and then you see a function here that's being declared. And then this string. Now, this string to us doesn't look like anything. It just looks like a lot of garbled text, like it's indecipherable. But often when you see an indecipherable string like this, the malware is using some type of obfuscation. And so here, when you see a function that's being called here, right next to a string of indecipherable text, chances are that that is a deobfuscation function. So first, I'm going to remove this, as you weren't supposed to see that at first. But I will go to this function. So just do Control F to find where the function is declared. So you can see here where it says function, this is our function declaration. So also, so this here, this is the parameter that's being passed into the function. So this is the string that's being passed in. And so you see an empty string being declared right here on line 99. And then here we're entering a for loop. So as I discussed before, in source code level obfuscation, there are some limitations for the malware author. Like there are some statements that are valid, that have to be like the return statement and the for and if, that can't be like, that has to be written as is there. So here so this is the for statement, and then so you see, so this is the input, like this is the parameter that was input. So let's just rename this for now to let's rename it to input string. I don't know. Yeah, input string, and do a replace all, so that will replace all instances. So what I just did, I did control and then H. You can also go up to, where is it? Oh, find and then replace. So it's control H. So you can do that too. So yeah, so this is the input string. So now, so we see here, starts at 0, like a typical for loop, and then it iterates until the length. So that will take you to the last character of the string. And then it iterates by 1 every time. So it's iterating throughout each character in the string. So we can do index. So we can just call this index. So again, control H and then replace all. So you do find, and then it will auto. So if you highlight that, it will auto populate the variable, and then you just click replace, and then it will replace all, and it will replace all instances of that variable. So now this is a lot clearer, this line. So it has an index and it iterates throughout each character in that index until the end, until the length. So that's the last character. So index modulo 2 equals 1. So if you're not familiar with, so what this line will do here is it will check, basically it just checks if a character is if the index is an odd number. So this will only be executed when the index is an odd number. So will only work in odd numbers. So then you have a variable here, and then the input string. So substring, if you're not familiar with what substring does, good thing that I like to do is look on the MSDN. So that's like the Microsoft Developers Network, and that will give you information about all the functions in JavaScript. So that's a good reference that I like to use when I'm not sure like what a function does, or I need like a refresher on, and also we'll show you the function and then like the expected parameters of that function. So you can see, so the substring method returns a portion of a string. So starting at the specified index and extending for a given number of characters. So for example, the string is Mozilla, the substring will, so this starts at character 1, and then it extends for 2 characters. So characters start at 0. So 1 would be the second character, so it would be the O, and then 2, so it prints out 2 strings. And then if you don't specify if you don't specify a length for how long the character should, for how many characters you should print, it will just print all of the characters after this index. So it starts at character 2, which is the Z, and then it prints everything after that. So that's what the substring function does. So then we know here, it starts at whatever the index is, and it only continues for 1 character. So it only prints that, it only gets that 1 character from the index. So you can probably call this something like get character. And then, here, so it will get the character, and then it will add it to the rest of the string, basically. So it starts So you have this string. So it's appending all of the characters to a string, essentially. So yeah, so it's only grabbing the odd numbers of the string. And also, if you notice here, it's actually reversing them. So if, for example, if you have like a string like, well, let's do like this since it's odd, but so if you have this string, say this was our input string right here. So it would only get, so the index starts at 0. So only when the index is odd will it get a character. So this is odd, so we'll get the character A. So then get character will get A, and then this will just add it to the, so right now this is just an empty string. So this will just get the character A. So then, but then when it gets B, because it will skip A because that's an index 2, which is even. So then B, it will get the character B. But then here, since the character is obtained first, it will add it like that. So it will actually be backwards. So, and then it will do the same thing for C, because it's adding it to the existing string. So, but it's adding the character before the string, which essentially prints it backwards. So, but that is how the deobfuscation works. But luckily for us, there's a lot easier way to get to deobfuscate functions. So there I just showed you basically like the static analysis way, just to get you more familiar with how JavaScript deobfuscates, how like JavaScript can deobfuscate malware. But luckily we have a lot easier of a way. Oh, Graham, did you want to say something?
Yeah, just so you know, we're about like 10 minutes left.
Got it. Okay,
Yeah.
I'll try to speed it up here. Okay, so luckily you can do wscript.echo, and then that will obtain, so this deobfuscate, so let's just call this deobfuscation. So Control H. Oh, that was not the right character. Not the right. Oh, okay, so yeah, this is the right one. So then I'm going to do deobfuscate. All right, so then wscript.echo. wscript.echo also allows you to print multiple variables, which is helpful. So we can just print them all on one line.
So wscript echo is just our way of printing the information to screen.
Yeah, correct. So wscript.echo will print the resulting variables to standard output. And then to actually, so first to actually get the result of wscript echo, then we'll use C script, because that will print it to the Windows command prompt. So then we'll get the results of the variables. So first, I just want to, so as discussed, you can really put anything here, like you can put not a valid function, and then it will just stop the execution, so it doesn't continue executing the program. So let's Control S to save this, and want to go to the folder that your sample's on. It should be the downloads folder, and then you'll want to run C script. So C and then script, C script, and then sample.js. And if you do tab, it will autocomplete. So C script and then sample.js. Okay, so we're getting an error here. So let's see what that could be related to. Oh, okay. So it's, I don't think this character should be there. Oh, yes, here's another thing. So as Evan was discussing before, the function is sleeping for 10 seconds. So in order to stop that from happening, we just uncomment this part here, and then Control S to save your changes. And then, so here are the results of those 4 variables. So we have a string here, then you have a URL here, and then those look to me to be HTTP response codes, although we'll look at those. Well, we might not have time, but we'll always can look at those later. But this here is the URL that allows us to, so that this is where we obtain the next stage of the malware from. So this is what's known as a command and control server. So this will host the malware, and also some often command and control server it will like it will communicate with the infected host and send it commands to control the infected host. So that's what that, so this, we can see these are called in order. So let's just, so this, we don't know what this is. We can just call this secret code for now. And then this, though, we know this is the URL. So Control H and then URL. And then these, what you notice about these two, so these are these characters here that look like, these parameters here that look like response codes. So then you notice here, these are actually, I don't think it should be that. These are the 2 variables that are passed into the send request function. So we can just call those parameter 1 and parameter 2. So then we can get rid of that, and let's briefly take a look at this function right here. So highlight it, do Control F to find where the function is declared. So you see, so here it's declaring new names for these variables. So we have to change that again, param1, and then param2. So this checks if the parameter is undefined. If so, it sets it to false. Here's just some empty strings that it declares. This is an equal sign, so we can rename. Well, let's look here first. So, well, actually, since we only have a few minutes left, I think I'll want to go a little further here and go to this part right here where it's declaring the XML HTTP object. So I discussed that in the slides, but that's a built-in object. Well, here it's using a slightly different method, but it's a built-in object of Windows script host that will get the, that can make a network connection. So as we saw before, so it's making a post request to that URL, and then we're not going to look at this, but this is essentially just encoding those 2 parameters in a certain way so that the server can understand them. So then it sends that as the body of the post request, and then this gets the status. So this will just see if it will get the status code. So then if the status code is 200, then it will attempt to get the response. So the response of the post request usually would contain the next stage of malware. As of now, since this malware has been out, it was something I originally found last week. So by the time I found it, the malware was already taken down. But let's look here and see. So this will check if the post request is set to 200. So 200 means okay, that it was successful, that the client was able to reach the server. So let's just check here to see what the result of that is. Just do exit, then save, and Control S to save, and then this should print the status code. 200. So yes, the server is still up, but I did check previously, and the malware, so the body of the post request is empty. So that means that probably that the malware was taken down, or that the server is somehow like the parameters we sent weren't what the server was looking for. So maybe then it didn't send the malware, but likely scenarios that the malware was already taken down. So then I'll just look a little bit to see like what would happen if the post request did contain something. Then what would it do? So then it would call this function. So this is so we'll just say this is the response of the post request. So then it will call this function here. And then, so this, I'll just explain this at a high level. This is a deobfuscation function. So this is so substring looked at before. So it will start at character 0, iterate 2 characters. So this will just get the first 2 characters of the string that's the body of the post request. Whereas this part, since this will start at 2, but it will get everything after that. So this gets everything, the first 2 characters, this gets the last, everything else except the first 2 characters. So then this is just iterating throughout here. And so what this is doing is it's using this as these first 2 characters as a key to decode that. And if you look at this function here, it's using a XOR operation. So it's using a XOR operation. So this here is the original. So this is the like everything except the 2 characters. And then this is the index. So it iterates throughout an index, and then it XORs it by the first 2 characters in the response code. And then the last thing I will show you is, so then it will do this function. So this function here will go down. So this is the part that will use eval to evaluate the statement. So I think Tarek was talking before, like about how eval, like when eval is called, it will there will be a signature, like it will alert signature detection. I'm not sure if this is like a way to get around that possibly, since it's using like this and then calling it a variable. I'm not sure, but this will evaluate the rest of the code. So this is JavaScript. So the next stage is JavaScript code, and then it will evaluate that. And then that's how we will get the next stage of our malware. So that concludes the demo at a high level. I know we didn't get time to look at like each granular detail of the malware sample. If you want to look a little bit more into that sample, you're welcome to. It's on as we discussed, on the malware drive. And then there's also another malware sample called other.js. And that's, you can look at that one as well. That's another malware sample. So that's concludes the demo. Anything you wanted to say, Bramwell or Evan or Tara?
Thank you for the nice presentation. I think going forward, just kind of point of information, some of the stuff that we might be headed towards in the future. So we can look at the analysis of malware, which we've done today, looking at JavaScript as a delivery mechanism. But we also might look at the creation of malware. How do you actually go and create malware? How can you create a malicious Office document? How can you create malicious JavaScript? So we'll learn about some of that stuff as well going forward. So it's not just going to be only one thing. I think kind of the main idea for us starting out is the first few meetings probably start at more basic introductory level. Perhaps later in the semester, we may get a little bit more advanced. We'll just see what the membership is interested in. Again, if any of you have a desire to be a speaker on a topic, just feel free to contact the leadership, which is, I'm not a leader, I'm just a faculty. Contact Evan or contact Odin. And also if you have ideas for topics, then something you want to see presented on, then reach out to them.
Yeah, that sounds good. And as
note.
Bramwell was discussing, oh, is somebody talking? Sorry.
Yeah, sorry. Quick note. Also, JavaScript exists on macOS. It's called JXA. It's called JavaScript for Automation on macOS. You can write a JavaScript on macOS and execute it as exactly as this one. But the only difference is you can't just double click it to execute. You have to execute it from the terminal. So still malicious, but it's very powerful because you can import C and Objective-C libraries using JavaScript. Makes it extremely powerful.
Evan?
Oh, yeah, I also wanted to say that I have some business cards up here up front. If anybody is interested or needs to get in contact with me for any way, feel free to grab those and you can just, it's got my email on it and everything.
All right, I think other than that, unless Odin has any closing remarks, our next meeting then should be like 2 weeks from now. It's every other week.
Yes, I did just want to say, as Dr. Brizanine was mentioning about that we might look into creating some Office docs or JavaScript attachments. I would definitely be interested in doing that in probably a future meeting or maybe the next meeting or the meeting after that. In addition, I also probably want to start looking at some dynamic analysis tools for analyzing JavaScript dynamically, but I really like the idea of looking at creating malware. I think that would really be a cool topic, a very interesting topic. So thank you everybody for attending and we will see you
On a
in
second.
a couple of
Does
weeks.
anybody in the in person here have any questions or anything before we go? You can just speak with our like ceiling microphones. Nope, no questions. All right, thank you, everybody.